surface areas and volumes of solid object. See, solid object, that means three-dimensional figure. So first figure is cuboid. Now see, cuboid. Example of this cuboid is matchbox. Now see, cuboid is a solid figure bounded by 6 rectangular faces where the opposite faces are equal. See, the cuboid is a solid figure in which there are 6 rectangular surfaces. See this matchbox, observe this figure. All the surfaces are rectangular where the opposite surfaces are equal. Now see, the best example of cuboid is also, you have your textbook, notebook. These are the examples of cuboid. See, their opposite surfaces are equal and each surface is rectangular. So this is a cuboid. Now next we are going to study dimensions of this cuboid. See, the dimensions of cuboids are, first one is length. See, this is the length which is denoted by small l. Then this is known as breadth, which is denoted by b. And see, this is a height which is denoted by small h. Now next we have to study formulae for this cuboid. See, dimensions of cuboid are L, B, H, length, breadth and height. So first formula is total surface area of cuboid. See, cuboid has total 6 surfaces. So total surface area of cuboid, that means surface area of each rectangular part. So total surface area will become 2 into bracket LB plus BH plus LH. See, each surface is 2 times, na? So 2 into bracket LB plus BH plus LH, 2 is common. You have to calculate surface area of base, surface area of side faces and surface area of back and front faces. Next, vertical surface area of cuboid. See, remember student, cuboid has total 6 surfaces. Out of this, 4 surfaces are vertical. So you have to calculate vertical surface area. That means surface area of only 4 surfaces, that is side and back and front. So vertical surface area of cuboid is equal to 2 into bracket L plus B into H. Next one is volume of cuboid. See, volume means capacity of any figure. So volume of cuboid is L into B into H. One more formula is there. Length of the diagonal of cuboid is equal to root of L square plus B square plus H square. Next solid figure is cube. A cube is a solid figure bounded by 6 equal square faces. All surfaces are equal and all are square. See, all the sides of the cubes are same. For cube, there is only one dimension, that is length. See, for cuboid, there are 3 dimensions, L, B, H. But in case of cube, L, B, H, all are same. Therefore, you have to remember, for cube, there is only one dimension, that is length. So, first formula for the cube is total surface area of cube 6L square. Next, vertical surface area of cube is equal to 4L square. See, cube has 4 vertical surfaces. Therefore, vertical surface area is equal to 4L square. Next one is volume of cube. See, volume of cube will become L into L into L, that is L cube. So, student, for cube you have to remember total surface area 6L square, vertical surface area 4L square and volume of cube is equal to L cube. See, the next solid figure is right circular cylinder. A right circular cylinder is a solid figure bounded by two equal circular faces and curved surfaces. See, for cylinder you can observe one surface is curved and there are two plane surfaces which are circular, which are circle. For example, best example of this right circular cylinder is unsharp pencil. You have a pencil. See, it has a one curved surfaces and two equal circular faces, bottom and up. As well as you can consider refill of your pen. See, only you have to consider refill in which part ink is filled. That point you are not going to consider. See, it is again example of cylinder, one curved surface and two plane surface. So this is a right circular cylinder. For right circular cylinder, again we have to study dimension. See, one surface is curved. For curved surface area, we have to consider height and two surfaces are plane. See, whenever there is a circle, one dimension is radius. So for right circular cylinder, student, dimensions are R and H. See, both the circular surfaces are same. So radius will remain same. So dimensions are R and H. Now let us study formulae related to right circular cylinder. First one is curved surface area of right circular cylinder, 2 pi r h. See, curved surface area will be 2 pi r h. Next one is total surface area of right circular cylinder. It is equal to 2 pi r into bracket r plus h. See, for total surface area, you have to consider curved surface area as well as two plane surfaces, that is area of the two circles. Area of circle is pi r square. Two circles are there, therefore it will become 2 pi r square. And curved surface area, already we have 2 pi r h. So 2 pi r common. So you have to remember total surface area of cylinder is equal to 2 pi r into bracket r plus h. Next one is volume of cylinder. It is equal to pi r square h. So student, you have to remember only three formulae for cylinder. First one is curved surface area, 2 pi r h. Total surface area, 2 pi r into bracket r plus h, and volume pi r square h. Now let us start with right circular cone. See the right circular cone. Now see the best example of right circular cone. You have ice cream cone, then you have birthday cap. See, for cone there are two surfaces. One surface is curved surface and one surface is plane surface, that is circular surface. Now for cone, dimensions are, see, this is length of the cone which is known as slant height of the cone and it is denoted by L. And see, this is known as perpendicular height of the cone. See, it is perpendicular to radius which is denoted by H. So student, remember, for cone you have two types of height. One is slant height which is denoted by L and one is perpendicular height which is denoted by H, and R is the radius of circular face. So for cone you have to remember three dimensions: slant height L, perpendicular height H, and radius R. Let us start with the formula. First formula, to find the slant height, L square is equal to R square plus H square. See, in the diagram we have right angle triangle, therefore you can use Pythagoras. You will get formula L square is equal to R square plus H square. Curved surface area of the cone. See, curved surface area of cone is equal to pi r L. Next one is total surface area of cone is equal to pi r into bracket r plus L. And last one, you have to remember volume of cone 1 by 3 pi r square h. See student, for cone you have to remember 4 formulae. First one, L square is equal to r square plus h square. Curve surface area is equal to pi r L. Total surface area is equal to pi r into bracket r plus L. And volume of cone 1 by 3 pi r square h. Next figure that we have to learn is frustum of cone. Now see how frustum of cone is formed. If the cone is cut off by a plane parallel to base not passing through the vertex, two parts form as, see, if you cut the cone parallel to its base but not passing through the vertex, then you will get two parts. See, one part is known as, see, a part towards the vertex, that means upper part is known as cone, and the remaining part of that is known as frustum of the cone, the part which is left over on the other side, that is towards the base of the original cone. That means if the cone is cut parallel to base, you will get upper part cone and the lower part is known as frustum of cone. See the examples of frustum of cone. Bucket. Bucket is the best example of frustum of cone. We have one more example, glass. Glass is also example of frustum of cone. Now let us see how this frustum of cone is formed. See, consider a cone. Already we know dimensions of cone are height h and radius r. So see, for the cone AB is the height h2, radius r2. If you cut this cone parallel to its base, then you will get one more cone. You can say it is a newly formed small cone. For that cone, radius is r1 and height is h1, right? And this remaining part is known as frustum of cone. So let us see formulae related to this frustum of cone. See, you can remember this formulae with the help of formulae for the cone. See, slant height of cone. You have slant height of cone. Slant height of cone is L is equal to root of r1 square plus h1 square. r1 square plus h square. Slant height of cone is equal to root of r square plus h square. See, instead of r, now in frustum of cone there are two circular face. That means there is only change in r. Remaining formula will remain same. So you will have slant height for frustum of cone is equal to root of h square plus r1 minus r2 the whole square. Next formula is curve surface area. See, you can compare with cone and you can write, you can remember the formula for frustum of cone. For cone, curve surface area is pi r L. See, there is change in r, na? So instead of r, you will have pi into bracket r1 plus r2 into L. So curve surface area for frustum of cone is equal to pi into bracket r1 plus r2 into L. Next is total surface area of frustum of cone. See how to remember this total surface area. See, for total surface area, you have to consider three surfaces: curve surface, base and its upper surface area. So curve surface is pi r1 plus r2 into L. See, base and upper surface is circle, na? And what is area of circle? Pi r square. For base, pi r1 square, and for upper surface, pi r2 square. So total area of frustum of cone is equal to pi r1 plus r2 into L plus pi r1 square plus pi r2 square. And next we have to remember volume of frustum of cone. See, very simple. For cone, volume is 1 by 3 pi r square. There is change in r. Instead of r, you have to write r1 square plus r2 square plus r1 into r2. So, volume of frustum of cone is equal to 1 by 3 pi r1 square plus r2 square plus r1 into r2 into h. In this way, you have to remember 4 formulae for frustum of cone.